to model a pendulum, okay, a simple pendulum with one link as I've shown here in the figure. What then I'll do is then I will show you how to control the pendulum using velocity control. So that's setting up to spin at a certain speed, position control, set point control, that is.
Okay, Bonso,
Yeah,
I have a quick question. What is the best way to save our work? Like the what we just did with the sphere on Coppelia?
it's saved as a TTT file.
Okay, let's
So
see.
when you
So
say file save,
Save scene or
yeah,
save scene?
so file open, it was, so you say file save scene as, or save scene. If you say save scene, it'll say what name, and then you give it a name, and then it'll be saved as a TTT file.
Okay, got it. Thanks.
Okay. Yeah, so then I will talk about position control, and then finally, which is I think most important here, is torque control. How do you set up a torque? And I think there are the three modes you typically want any joint to move. Okay, so it'll cover all three. Okay, so let's get to modeling. This is slightly more fancier modeling than what we've seen here. So file, close scene. Okay, so let's do the modeling. Okay, so first what we'll do is we'll make a stand. So say add primitive shape, cuboid, and I'm going to make this, my pendulum is going to be 1 meter long, so maybe I should make the stand 1.5 meters. Okay, there it is. Okay, next what we want to do is, okay, let's call this stand. Okay, next we want to do is we want to pretty much set up a joint, put a joint on top. So I'll say add joint, and there are three options. We'll pretty much be focusing on revolute joints. Okay, so revolute joint, and when you click that, it actually is buried inside the ground. We want to move it up, and we also want to change the dimensions. So let's move it up first. So what you do in this case is, if you want to translate something, you press on this icon. If you want to rotate something, you press on this icon. So let's click on that. Okay, now the question is, what's the best way to do it? Well, you can manually move it, but you know that thing means that you might be off by a few centimeters here and there, and that's not a good way to do it. I always like to use this position icon and feed in the values. Okay, I know that this is 1.5 meters long, so I would need to move 1.5 meters along the x direction. This is my best case. So if I move there, and if you see carefully, okay, if you zoom in here, okay, first of all, you see that it's pointing upwards. We don't want it to be point upwards. We want it to actually be along this axis. The second thing we want is probably to make it bigger. But first, let's rotate it by an angle so that it's along this axis. So if you see here, you have the x, y, and z, and it looks like I need to turn it about the y-axis. If I turn about the y-axis, it should probably line up such that the axes are along the x-axis. So let's click on rotate, which is right here, and then we'll say this is about the world, and I'm going to say, well, orientation about the world, I'm going to say 90 degrees. Whatever you put here is going to be in degrees, and whatever you put in the Lua code is going to be in radians. Remember that. It's confusing, but that's how they made the script. They made the whole program. Anything here in the GUI is degrees, anything in the script is radians, and you can figure that out easily by just entering the numbers. So 90 degrees. Okay, and then if you want to make it big, make it big, click on revolute, and then it'll show you the length and it'll show you the diameter. Maybe I want to make it 0.1 and see how it looks. That looks good. You want to extend it a little bit more, make it bigger, maybe 0.2. Okay, that looks good. Maybe I want to go a little bit more, 0.25. Okay. And then you can of course move it back and forth. Okay, now you can always simulate it. Let's try to simulate it. So if you run this, nothing happens. Okay, things are stable, so they're staying properly. Okay, now we want to do is we want to create this link and attach it to the joint. So let's say add primitive shape. Let's say cuboid, and we want it to be 1 meter in length. Okay, so you can see it's again buried inside this. So what we'll do is we will do translate, and then we want to move it. Okay, so it's basically telling you 0.5. What does 0.5 mean? This is 1 meter long, and if it's 0.05, it means that the center of mass, or sorry, the geometric center of the link is 0.5 meters from the ground world frame, and the world frame is, hold on, let me just rotate this. This is 0, 0, 0 right here, and so this point is clearly along the z-axis. It's 0.5 meters from the z-axis, and that's why you see it's 0.5. Okay, so what we want to do is we want to move the center by a distance of, we want to move it from here all the way to by 1 meter, so that when you move it to 1 meter, so that it'll line up perfectly here. So let's click that, make it 1 meter, enter, and so you see it just now it's over here. Now we want to move it slightly towards you, which means that along the red line, and the red line here is the x-axis. So I want to move it maybe 0.1. Okay, we move it slightly more, 0.15 say, and then you want to see how it looks. You can actually turn this. Okay, so the thing to note here is that it is not colliding with, it's not colliding with the stand, otherwise it'll hit the stand when it's moving, and that you don't want that to happen. Now maybe we don't like this pendulum, the joint, to be like this. Maybe we want to move the joint slightly to the right, so that part of it is covered, just looks aesthetically pleasing. When you do the simulation, I'm telling you, the simulator does not care where the joint is relative to the location. Okay, it's not a physical system, it's only the way it's defined here. So if you want to make it look nice, it's fine, but if you don't care, this should also work the same way it would if you had not moved the joint. So let's move that joint by a small distance in the x direction, say 0.05. It's looking good. Maybe a little bit, 0.075. Okay, now it looks good. Okay, so now let's rotate again. Okay, now. So when I say save, files, save, it asks me for a name, and then I can call it pendulum.ttt, or you can just say pendulum, and it's saved. Okay, now let's simulate it, and clearly the link is not attached to the joint, so it's going to fall down. So what we need to do here is we want to tell the CoppeliaSim that the cuboid, or let me call it pendulum, is linked to the revolute joint. Let me call that joint. Okay, so I want to sort of say make the pendulum a child of the joint. So I'm going to move this, click that, hold on to the mouse and drop it on the joint. And so when you do that, now pendulum becomes part of the joint. Joint is the parent, pendulum is the child. And now let's run this. That's interesting. Okay, we also want to make the joint a part of the stand, right? So we'll just select that, hold on to the mouse cursor and drop it onto the stand. And now this whole thing is a system where the stand is the parent of the joint, which in turn is the parent of the pendulum. And now let's run this. Okay, this is what I would expect it to see. Since this thing is not in equilibrium, well, there's an unbalanced force, it's actually falling down, right? It will fall that way because this thing is as mass. So what we can do here is one of the two. I can go to stand, and where's that common? Maybe we can call the stand a model base. Let's see if that changes anything. That doesn't change anything. Okay, so what we need to do is we want to understand that the stand is not really in the simulation. It's basically a fixed entity which should not have dynamics. So what you need to do is go to stand and go to common, and I'm trying to see where I can specify its properties. So this dynamic properties seems to be the one. So if you look at the dynamic properties, there are two properties. One is board is respondable, one is dynamic. Okay, the respondable is something to do with collisions. It will detect collisions or not. The dynamic one is to say if that is dynamics or not. So I'm going to uncheck this, okay, because I don't want the stand to have dynamics. Okay, now let me play this, and things don't move because now what has happened is I've sort of glued this to the ground by saying that it doesn't have dynamics. So there's no unbalanced force acting on the stand. Okay, now let's stop it. There's no motion here. Let me click on joint, and I'm going to set the initial position of the joint. Let's set it to, let's say, 10 degrees. Do that. You see that it's moved by 10 degrees because the joint actually moves by 10 degrees. And now if you press simulate, you can see it's moving. Now the motion doesn't look realistic, right? It looks like it's jerky, but that's because I did not turn the real time on. So let me turn the real time on, and now play it. So now it looks more realistic. Okay, if you want, you can play with this. You can set it to, I guess, 60 degrees, and then play it. Okay, at this point I always recommend pulling up a graph. So add a graph. We always want it to be on the bottom left corner, bottom left corner. And then let's double click on that and say that we need to add a new data stream. In this case, we want to add the joint position. So I'm going to see if there's something like joint position. There you have joint position. Let's click on that and say joint position for the joint. Say add, and let's call this angle. The color is fine. Then say add a new data stream, and let's add the velocity. Velocity. Okay, joint, add, and call that velocity. And then let's change the color to, let's say, blue. Okay, and the last thing maybe we want to do is add a torque. So go here, try to search for joint torque, force or torque, and say joint, add, and then let's call this force. I think this is torque. It's a force if it is a prismatic joint, in which case it's a linear force. If it's a rotary joint, then it's a revolute joint. It's pretty much a torque. So click that, adjust color, and then let's make that green. Okay, now we should see a plot of angle, velocity, and torque. Now, interestingly, the torque is 0. That's clear because we did not supply external torque to the system, right? So that's why the torque is 0. It's moving because it's gravity. So if you look actually at joint, then you see there's something called mode, and there are different modes you can set it up. In this case, you can also set it to passive mode if you want. Okay, so that didn't quite work, and I really don't know what that passive mode is. It looked like passive mode should be 0 torque, but you can figure this out. You can find out in the documentation why passive mode does what it does here. It looks like we need to put it in the torque mode. Okay, and then there are other modes which will come later. The one which I think you want to use eventually is inverse kinematics mode, which we'll talk a little bit later. but torque mode is fine now. Okay. Okay, so that basically completes the passive mode, modeling and passive mode. Any questions?
I have a quick question for on the plot. Is there a way to have like a sliding window um, instead of it, compressing into the same size?
Yeah. Okay, this is something which I have not investigated. I don't know how to do it.
Okay.
My hunch is you can write a script here, and I think that there might be an example on how to do that by writing the right script. And maybe it's just a matter of figuring out the right script and copy pasting it so it'll do what you want to do. The other thing you can do is you can actually get data in MATLAB, and we'll do that a little bit later. I want you to be
Okay.
careful with the commands. But once you get data in MATLAB, you can do anything you want in MATLAB
Got it.
or Python
Thanks.
or whatever. Okay, so let's get to the next part. Now, let's so we did simulate passive mode. I'm going to show you how to do velocity control, position control, and torque control using the GUI and Lua. Okay, so GUI is the most easiest one, but that has limitations because you sometimes want to maybe switch between velocity and position control, and you can't just do that using the GUI. So let's do the GUI part first. Okay, so everything on doing position control in the GUI is in the joint properties. So double click joint, okay, and then you see this. You can see torque and force mode. Now here, press dynamic properties. And if you do the dynamic properties, this comes up. Okay, so this is saying if you want to enable the motor. So let's enable the motor. Okay. Now the first part of this is actually position control, sorry, the velocity control and torque control. Okay. On top of this, if you click on this control loop enabled, then it does position control. So let's just focus on velocity controls first. Now, let's say that we want this thing to spin at a constant rate of 1 revolution per second. Okay, what is 1 revolution per second? It's 360 degrees per second. So as I said, everything in the GUI has to be in degrees. So we want it to be at 360 uh, degrees per second. And then the torque is something which you say that, when it's trying to pretty much control this, it's putting up a torque, and this is basically setting up how much torque it's allowed to go. So if you wanted to execute at 360 degrees per second and not hit a torque limit, then you want to just blow up the torque limit to, I don't know, 1000. So it'll never hit that joint torque limit. So let's set this up. And if you like, I can set the joint angle to be 0. And now let's run this. So now it's spinning, I believe, at 1 revolution per second. And now you can see that the velocity is constant. It's actually 360. The torque is non-zero because you need a non-zero torque to move. And then of course the position is changing. So I can't see this limit, but looks like that limit is probably 50 or something like that. So if you want to see a torque limited pendulum, then what you can do is go here and change this torque limit so to maybe 25. Okay, this is just saying that now what's happening is it requires about 50 newton meters torque to spin, but you're limiting it at 25. Clearly it's not going to spin. Now let's see what happens. So you can see it's trying to go all the way, it's trying to put, but it maxes out on the torque, and so it can't quite make it spin. Okay, I'll stop this. Okay, so let's do, uh, now that we did uh, velocity control, let's do position control. First, we'll set this limit to a crazy high number. Let's do control loop enabled. And when you do this control loop enabled, you can see automatically the velocity goes away, because you can't have position control and velocity controls. Can be one or the two. So here you're pretty much setting the uh, position control. So let's say that we want to set the position to be 30 degrees. Again, everything here is in degrees. We want a velocity limit. So just this is like the same thing as torque limit earlier. So you want to specify big enough limit so that it never really hits that. So let's say 1000. Okay. Well, that's actually small because degrees per second. Let's just make it 9000. So it never hit that. And now we need to set PID control gain. So let's say 100 integral 1. Always like to put a small integral gain, and then velocity is 10. Okay. Now here I set it to go to 30 degrees. Let's see if it goes to 30 degrees. So there it is, 30 degrees, and it's shaking because of course I need to tune the gain so that it doesn't shake. Okay, what if you want to go to minus 30 degrees? Just go here and set this to minus 30. Okay, and then run. And so it goes the other side. Okay, so that's basically position control. Let's see how to do the torque control. Okay, the simplest way I can illustrate torque control is what we'll do is we'll set this to 90 degrees. Okay, now when it is at 90 degrees, and if you want it to be at 90 degrees, just hold on to that position, then you need to supply a torque equal to the gravitational torque. So what we'll do is we'll compute the torque it needs to hold on to its um, to hold it in that position, and then we'll supply exactly that much torque so that when we start the simulation, it'll just be on that position. Right now, if you let me go here, disable this, disable this. So if you let it go, it's going to go swing back and forth, right? We want to just hold it to that position. So first we'll do is, let's see the mass of mass of the link. I think it's 10. Yeah, it's 10. So it's 10. We also know that gravity is 9.81, and then we also know that the length of this is 1 meter, which means that the center of mass is about zero point 0.5. So we can compute the gravitational torque needed, right? It is going to be 10, so it's going to be mass times gravity times the half of the length, because the length of the pendulum is 1 meter, but the center of mass is at half that distance. So that's going to be 10 times 9.81 times 1. So it's going to be 49.05, which means that if I put 49.05 Newton meters torque, then it will basically hold onto the position. So let's see if that's true. So let's go here and get to joint, show dynamic properties. I'll enable the motor, and this is, by the way, also the way to control the torque. Okay, what you want to do is, in this case, is earlier you set up the velocity to be a set value 360 in that case, and then the torque was maxed out, right? So it goes to do velocity control. What you want to do here is you want to exactly reverse that. First we'll put the velocity to be an extremely high value, so 9000, so it'll never hit that limit, and then we'll put the torque we really want it to, so it'll be 49.05. Okay, and we should just run this now. So you can see it actually stayed there, it didn't move. Okay, to really verify this, what we can do is we can slightly change the torque and see what happens. So let's change it from 49 to 40. Okay, so this is supplying less torque than it actually needs. So now it will actually sag down. You can see it sag down. It's trying to put in a little bit more, and then that's why it goes back and forth. But I hope you get the idea that that's how you set it to do torque control. That is, you max out the velocity and then you put exactly the right torque. Now, other question is, how can you do this for minus 90 degrees, or turn the pendulum the other way? Let's first set the pendulum to be the other way, minus 90. Okay, now I want to supply the same torque. Now clearly the torque needed to hold on to that position is negative 49.05. Okay, so go here, you put 9,000, which is an extremely high value, and let's put minus 49.05. Okay, you can see that what's happening when I put minus 49.05, it actually became 0. The way this works is you cannot set a negative torque, you can only set a positive torque. So when you put a negative value, it actually rounds up to 0. So if you put minus 2, it will be 0. So you are restricted to only a positive torque. So then how the hell can you get this to stand in a minus 90 degrees position? The only way you can do this is clearly to set the velocity to be negative. Let's set that to negative 9,000. Okay. So once you set it to negative 9,000, it stays. And then if you run this, my hunch is it will stay. So you cannot set a negative torque. You can only set negative velocity, and that's how you get it to do negative torque. Okay, that's how they've set up the system. Okay, I'll kill this. Any velocity controls, there's a command called set joint target. Well, I switched this. This should be target velocity. This should be target position. And then how to set the torque control using max force. Okay, so first of all, let's go to joint and then disable it. Okay, because I don't want to do it through. Well, we can also do it this way, which is basically we can set the motor enabled. Okay, and what we'll do is we'll then set the velocity using uh, the script. So first of all, let's create a script. Will be a insert new script. We'll call it it'll be a non-threaded script, which is doesn't need to be, it doesn't run real time. And then there's a bug which doesn't let me choose the associated object, so I need to close this and then open the scripts again. Now I'm able to choose that I want to associate it with, you can associate with anything, pendulum, joint, whatever you want. It really has no issues. I'm just going to associate with stand. Okay, so did that. Okay, now open the code. Okay, let's make them side by side so it's easier to write the code, understand what's going on. Okay. Okay, now let's go to the API and then search for velocity or joint target velocity, whatever you like. Velocity is more general, so here it is, joint target velocity. Click on that, and then it says this is how you set the joint target velocity. This command. It's really self-explanatory, so I'm not going to read it. Let's just put it in actuation. Or you could, by the way, put also in the initialization. That's fine. And what I need to do here is I need to give the object handle. I've not actually created the object handle, so let me just go and get it. So in this case, the object whose velocity I'm changing is not the pendulum or the stand, but it's the joint. So I need to create a joint handle. So let me call it joint as my handle. And then I'll say sim.get. What's the joint? No, let me see. What's the command for joint? It's called object handle. So get object handle is right here. And then the handle is for something which I named as joint. So I need to call here joint. Okay. So I got the joint. I'm going to put it here. Okay, and then I said, remember, we set a velocity of 360 degrees per second. When you're writing a script, you always set the velocity in radians per second. So here we want it to be pi radians per second, or 360 degrees. So I set it to be 3.14. Okay, I think that should work. But before we do that, let me just set the joint angle to be 0. Okay, and I just want to check if I set the motor is enabled. You can see it over here. Okay, and then you can see that the velocity is 0 right now. The torque is 0. I should increase the torque, otherwise it will not work. So let me change the torque to crazy high value, 1000. Okay, velocity is set to 0. Okay, so let's run this. You can see a couple of things here. First of all, it's spinning like it spun earlier. You also see that the target velocity has changed now in response to this input. Okay, so it basically sets from the Lua script. Wait, why isn't it 360? See. The 360 is 3.15. Just enter. Okay, now I'm setting it right from the GUI. Okay, that's 360. What's going on?
I think it should be 2 pi.
Yeah, right, 2 pi. So 6.28. Okay, so now let's run this. Yeah, it's very, you're right. It's very close to 360. That looks right. Okay, so we can now stop this. This works as expected. Okay. Now let's see how to set the velocity control. So one thing you want to do is, before you set the velocity control, is you need to enable velocity control, and then set up the gains you want. And then here you can see the position is 0. What we'll do is we'll set the position through the Lua script. So the command for that is, so it should be here, set joint target position. Okay, and syntax is very similar to that one. You just have to set the angle versus the position instead of the velocity. So space that, joint is the, and then position, let's say 30 degrees. Now, as I said, 30 degrees is going to be in radians. So it's going to say, I'm going to say 3.14, which is pi, divided by 6, that's 30 degrees. And now let's go. You can see it's doing the same thing it did before. I thought it would have set it over here. Interesting. I thought it would be 30 degrees here, just like previously. Why did it set? Okay, apparently it doesn't set it over here. Okay, that looks fine. Okay, now before I go to torque control, let me show you how to set position control in Lua script. That is, I had to check this over here in order to do the velocity control, and then check that to do position control, right? But sometimes you don't want to do that. You want to set everything through the Lua script. So let's just set all this to 0, 0, 0, 0. Disable this, disable that. Okay, now clearly this is passive and it's not going to move. But let's try to set the velocity. If you do that, it's not going to work probably. So it doesn't work. That's because what has happened is you have not enabled. Look here. You have not enabled the motor. So you need to first enable the motor and then do target velocity. So let's see how to enable the motor. Okay, first. So that actually is part of it's called get object float. So if you remember sometime back, for the projectile problem, we talked about initializing the velocity. Those were float parameters. We need to do something similar here. So let's just go to float parameter and then see all the possible parameters. In this, I'm trying to search for motor enable. So it's right here. So it says sim joint int param motor enable. This is what is used to set the motor to be on. What you need to do is you need to essentially set it to 0, which I believe is off, and not 0 for it to be on. Also, one thing to note is that this is actually an int32 parameter. It's not a float. So what I need to do is I'll copy this, or I can put 2000. Okay, let me paste it here. I'll need it. Then I also need, if you look at the here, I need get object int32, not float, but int, because that's setting an int. So go here. So I set int. Then I set, okay, I just need the syntax and I'm good. So syntax is this. Okay, so the output is, well, it says result, and I'm using the wrong one. It should be set. Hold on, let me go back. I shouldn't be using get, I should be using set. Set object int32 parameter. That's what I want. Okay, so let's just get this and then paste it here. So sim, I'll delete that first one. Okay, object handle. So in this case, the object handle is the joint. Then I need to set the parameter ID. So in the parameter ID is either 2000 or this number here, set this variable. Again, the final thing I need to do is give the value for the parameter. As I said, it shouldn't be 0 because 0 is disabling it. So let me put 1. Okay, so once I set it up, let me now copy paste the velocity. So I set the motor to be enabled and then I set the velocity. So let's run this. And now you see it spinning again at 6.28. Stop again. If you comment this out and run it, it doesn't move because the motor is not enabled. And uncomment it, and then it works. Okay, so that's position velocity control. Okay, so let's just write it down. Velocity control. Okay, now let's see how to do position control. Yes. So next I'm going to write code for position control. Okay, now there's a hint here. Well, first of all, let's just run this and you see it doesn't work because it's not enabled. If you look at the joint position control dialog, you see that the way you set up position control is you first enable the motor. So you need to first set it to velocity control. Then you want to check mark control loop enabled. So you need to do this step first, then do this step. And that's precisely what we need to recreate in the code. So let's first enable the motor in velocity control mode, which means that I need to take this, paste it first to enable it. Okay, so that's enabled. Next, we need to set control loop enabled, and that's actually a parameter. So if you go and search for parameters, motor enabled, you see that this is the second one, which is control enabled. So I'm going to go here. Essentially copy paste this line and then put this as my second argument. So this is basically enabling the position control. So that's int32, which is fine. Let's just run this. Okay, now if you look here, let me stop this. So you can see that it's not checked. The moment I run it, I just thought I saw it checked. Yeah, there it is. It's checked, which means that it's enabled. But you can see that it's actually not doing any position control. It's not really had 30 degrees. And the reason is because my PID gains are 0. I need to set my PID gains. And that last step is to set the PID gains. For that, we again go to the CoppeliaSim and see that the PID gains are set by these commands. So it's basically for P or 2002. And this is, you can see it's a float parameter. It is not an int32 parameter. So you need to change that get object, set object float int32 to set object float. Let's just do that. So this is what I need. So I'm going to copy this part. And then I'm going to set this to float. Then I'll copy this here. And then I need to set the position control. So that's 100. I have to do this for the I and D. Now, if you don't want to set the I, you can just leave it alone. It's really up to you. Let me set the I to 1, and then the D, let's say 10. Okay, I believe it will work now. So I set the velocity control, then position control, and then the PID gains. Let's run this. There it is. It's again at 30 degrees. Now, right through the code. Okay, let's stop this. Okay, the last piece is going to be torque control. Now, if you want to comment on a big chunk of code, then what you can do is you can use this way of commenting. Dash dash 2 square brackets, and then end 2 square brackets, dash dash, and then that piece is commented. Okay, so last part is torque control, and then we'll be done. Okay, now how do we do torque control? As if you remember correctly, we basically first enable the motor, which is basically doing this part. So I'm going to copy this part and paste it here. Then we need to set the target velocity to a very high value. So I'm going to take the target velocity and set it to a very high value. Let's say 9999. So it's a very high velocity. And then I need to set the maximum torque. Now we need to find a command for that. So the maximum torque, it's called max force. Set joint max force. We confirm that. Yeah, it's called set joint max force. The way it works is you set the object handle, in which case to be joint, and then you give the torque the force value. So let's just take this, copy, paste it here, and the joint handle is joint. And then if you remember, we had computed, if you want to hold it at 90 degrees, then you need to have 49.05. And of course, you want to set this to 90 degrees, otherwise it will not be in equilibrium. So let's just go to the joint, set it to 90 degrees. Okay. And now if everything works right, then it should actually just hold on to this position. So there it is. It's holding onto the position. Okay, now if you want to hold it to minus 90 degrees, then you need to go to joint, and let's say that we want to hold it to minus 90. Okay, as I said, the way you do it is you just set the velocity to be negative. So run. And now it's working. Okay, so now if you want to make it, independent of switching the values, you can actually. What I did was I basically have a new variable called sine, and then I said if you want to put a negative or positive torque, let's say that I want to put positive torque. Okay, so instead of switching the velocity, I just make the code do it for me. So if I say if torque is greater than 0, then sine should be 1. Else, I think the syntax is if this, then you do this. Else you say sine equals -1. Okay, and then you need to say end, just like MATLAB. Okay, so then I do is I just put sine times this, and then I can just put torque. So this basically takes care of uh, having to write positive, negative sign. It just does it for you. So you can then, in this case, I think it's you want to put a negative torque. So we run this. Oh, something is not right. If torque is okay, it should also be here. Sine times torque. Right, the torque should always be positive. So even if it's negative, it should always take a positive value. So now the sign takes care of that. So run this. It stays here. And then if you want to do it the other way, which is you want to set it up to minus 90, oh sorry, 90, then you just change this here and run this. So it'll stay. So you can actually write this as a function if you want. Let's see how to write this as a function. Uh, yeah, we can just make a function set torque end. So the input should be torque, and then it takes the torque. Okay, I'm not sure if, let's hope that this works. I've never written functions in Lua before. Let's see. Torque set torque, and let's say 49.05. Let's see if this works. Yeah, this works too. So then if you want to set negative, then you just go negative 90, and then in this case you want to set negative. It works. So here is a way in which you don't have to worry about what happens in the code, but you just set the torque you care about, and this code basically takes care of the torque. So that's basically torque control.